If at any point of your life you have ever taken physics, then you've probably heard of the Water Bottle Rocket Challenge, a test of all the concepts you have learned so far. This is our attempt at that challenge. But before you can understand how our rocket works, we have to explain some boring physics stuff. So I'm going to hand the mic to Michael, and hopefully he can explain.
Before we explain how we built the rocket, we must understand the fundamental forces at play, which include lift, drag, thrust, and weight. Lift and drag are not applicable to our current knowledge of physics, but thrust and weight were very much considered in the making of our design. Minimizing the weight while maximizing the thrust will result in the greatest acceleration because of Newton's second law of motion, F equals ma. In simpler terms, the acceleration is inversely related to the mass or weight and directly related to the force or thrust. Our group also wanted to minimize the rocket's mass because greater mass is indicative of greater inertia, or the tendency of the rocket to stay at rest and not accelerate off the ground. Finally, Newton's third law states that every action has an equal and opposite reaction, another reason as to why we tried to maximize thrust. Greater force of the water being expelled creates greater force of the rocket accelerating in the opposite direction. Also, because of the law of conservation of momentum, we know that the momentum of the water expelled must cancel with the momentum of the rocket. Producing greater momentum in the former will cause greater momentum in the latter and hence a higher flight. Another non-Newtonian force acting upon our rocket was impulse, also defined as force multiplied by time, mass multiplied by change in velocity, or just the change in momentum. Using these definitions, we understand why a greater thrust over a greater period of time will result in greater change in momentum and change in velocity.
Whew. Knowing all that, let's get started. We first got started with making the body of our rocket, where our capsule and water is going to go.
First step is to cut the bottom of the bottle.
We had two bottles that would become the base of our rocket. We took one of the bottles and cut the top and bottom off. But we did not throw out these pieces, as they would be significant later. But we then stacked the two bottles on top of each other and taped it all around. Now that we have the base, let's focus on the fins. We created these parallelogram shapes out of cardboard that we so carefully taped to the side of the rocket. The point of these fins is to stabilize the rocket so hopefully our rocket flies in a straight line and doesn't turn to the side from the wind.
You lined it up correctly then.
I did line up correctly.
Wait, let me see. What is that? I have full faith that you're gonna be able to hold the.
You're expelled. Get out.
Next, it's time to talk about the nose cone that I created. With some careful rolling, we were able to get this cone shape. We then taped 4/4 into the tip of the cone. The purpose of the nose cone is to reduce the air resistance, or quote-unquote drag, so our rocket can go higher. The coins are so the nose cone can tip over and allow our egg capsule to escape when we launch the rocket. Note that we had to remake another cone as our original one broke during testing, but this process was still the same.
Tape the coins in on the bottom.
The points?
Trap it.
Yeah, so they don't fall out. Yeah, and just like stick it down.
The parachute, created by Liz, does what you expect it to: make the egg fall down slower. It works by increasing a person's drag, which counteracts gravity. We made this out of trash bags and dental floss, and this was then attached to the bottom of our egg capsule, created by me. The hole on the top of the parachute is to prevent the egg from swinging back and forth.
Break our stupid With all due respect, I did see that happening. I just thought it
I'm
was
ready.
really funny.
Wait, give me countdown.
I mean, a little bit of fun might
Just like
sense.
go like,
One.
just like.
Last but not least, the capsule. We lined the capsule with cotton balls and leftover Halloween cobwebs, with a little area for the egg to sit. Remember when I said the top and bottom of the bottle would be significant later? Well, now it's later. The capsule itself was the leftover top and bottom of the bottle that we smushed together and taped. We hoped that the compact cotton balls would take the force of the fall, leaving the egg to be fine. Note that later we added sponges in hopes that it would take more of the impact of the fall. We attached the parachute to the bottom of the capsule and had the whole contraption sit in this crevice of the rocket. We then put the nose cone on top, and that was our design. As the rocket flew in the sky, the plan was for the nose cone to fall off, followed by the capsule, leading to the deployment of our parachute. If all worked as planned, then the egg should be fine. And with that, we were done with our rocket.
Is the camera angle good, guys? So, camera, this is our egg.
Now, you still might be wondering, what did we name our rocket? Well, if you paid attention in the beginning, you might know, but in just a second, you're about to see.
Wait, let's turn it into a bee.
Bumblebee. Oh, we can call it Flight of the Bumblebee.
Yes.
On the day of the launch, we were buzzing with excitement. See right there? And the only thing that could go wrong is if we dropped the egg. But obviously, we were super responsible, so there was no chance we were going to. Oh.
Okay, I just started.
In fact, not fine, but that's okay, guys. Parachute did not deploy.
In a dag.
It's a little rough, but everything else, it went super high. That was our only kind of thing that we had going for it.
So we kind of achieved the purpose of this lab. We were able to launch the egg 60 feet into the air, but we unfortunately did not return it safely to the surface of the Earth. Our design was amazing at getting the rocket to fly in the air, but the capsule and parachute did not work as planned. The capsule did not absorb enough of the force, so our egg took the heavy blow. Plus, I believe that as the rocket went up, the capsule got pushed in further and could not fall out as intended, hence why the parachute did not deploy. Maybe if we flipped the capsule upside down so the parachute was in the cone, the parachute could have deployed and helped pull the capsule out. We also could have used foam instead of cotton, as that might have been better at taking the brunt of the fall. Plus, if we had a block under the capsule, it might be able to fall out easier.
Even though our rocket isn't perfect, I'm still incredibly proud. Thank you for watching.